Hey guys, Professor Calculus is here, and today in this video we're gonna see how we should solve the integral of 1 over 1 plus x to the 5 dx with respect to x. Before that, make sure to like and subscribe, as it is free and you can always change your mind later. So let's go and see it. First, we need to factor the denominator, and using the sum of the fifth powers, using this identity, we can write this as x plus 1 times this algebraic expression, and we assume a product of two real quadratics like this for this x to the 4 power thing, and we're gonna get the following result. And now comparing the coefficients with the original quadratic, we're gonna get to find a and b, and we need two numbers whose sum is -1 and product is -1, and we're gonna get alpha is equal to root 5 minus 1 over 2 and phi to be equal to root 5 plus 1 over 2. Thus a equals to alpha and b equals to -phi. And now we need to write the complete factorization. So x to the 4 minus x cubed plus x squared minus x plus 1. It is actually equal to x squared plus alpha x plus 1 times x squared minus phi x plus 1, which is equal to x to the 5 plus 1, just multiplying by x plus 1. So now we need to do the partial fractions. We're gonna say and assume our ansatz of 1 over x to the 5 that can be written as the sum of a over x plus 1 plus b to the b x plus c over x squared plus alpha x plus 1 plus dx plus e over x squared minus phi x plus 1. And we can solve for a, b, and c, and d, and e by algebraic tricks, as you can see in this following animation. So a is a fifth factor, and using the other identities of the partial fractions, we're going to end up solving the exact values for a, b, c, d, and e, which we're gonna see in the following. So now that we have partially decomposed our fractions here, we can write 1 over 1 plus x to the 5 as the following. So the original integral would become the following, just split it into some integrals. And now this integral would become very easy to solve, especially the dx over x plus 1 part. So we need to handle the first quadratic fraction. So we can write it as the following. And we can integrate the derivative term like this. We can let u to be equal to x squared plus alpha x plus 1, and du is 2x plus alpha. Therefore, this integral would be the following. So, actually this integral would be equal to 2 over root 4 minus alpha squared, or tan of 2x plus alpha over root of 4 minus alpha squared. And j alpha would be equal to this. So the second quadratic fraction, j phi, we can use the same trick that we have used before, splitting the integral and using the u substitution to get the following result. So the quadratic integral of j phi would be equal to would be equal to the thing that you've seen. So I forgot to read the full description of it. So we can now simplify the constant and combine all three pieces of this integral. so we would get a better description of the integral that we need. Therefore, the final antiderivative of the integral is the following, that you can see, which is very hard to solve with ordinary methods, but hopefully you've understood the process of finding the antiderivative of this expression here. And if we differentiate it again, we're gonna get 1 over 1 plus x to the 5, which verifies the correction of our process. Thank you for watching this video. Please like and subscribe, and I'll see you next video.